You walk into a room full of strangers. Nobody knows you. You don't know them. And yet, within seconds, your brain has already decided who is safe. Not consciously, not deliberately. It happens before you can stop it. You scan the room and something pulls your attention towards certain faces, faces that look a little like yours. Same rough features, same skin tone, same way the eyes are set. And without any evidence, without any reason, you feel something loosen in your chest. A small, quiet signal. These people are probably okay. That feeling has a name, and the real answer to why you feel it is far stranger than you think. It starts not in a crowded room, but on an open savanna roughly 200,000 years ago. Your ancestors did not live in cities, they did not live in nations. They did not have governments or laws or any of the systems that now stitch strangers together into functioning societies. They lived in small bands, 50 people, maybe 100 at most. And in that world, almost everyone you would ever meet in your lifetime looked like you, spoke like you, moved like you, because almost everyone you met was related to you. Genetic similarity was not a philosophy back then. It was a survival filter. A stranger who did not look like the band was, statistically, not part of the band. And someone not part of the band was a potential threat. A competitor for food, for water, for territory. Your nervous system learned to read faces the way you now read warning signs. Fast, automatically, without waiting for confirmation. Psychologists call this the in-group bias. But that phrase makes it sound like a mild social preference, like preferring one coffee shop over another. It is not mild. It is ancient. It is structural. It is baked into the part of your brain that decides, before language even gets involved, who counts as us and who counts as them. Henri Tajfel understood this better than almost anyone. In the 1970s, Tajfel ran a series of experiments that would eventually become some of the most cited studies in all of social psychology. He wanted to know how little it took to make people favor their own group. So he created groups based on nothing, literally nothing. He told participants they had been sorted by whether they preferred paintings by Klee or Kandinsky. The groups were random. The criteria were meaningless. And yet, within minutes, people were allocating more resources to members of their own group and less to members of the other. They had never met these people. They would never meet them. But the label said same group, and that was enough. That is how shallow the trigger is. That is how fast the brain moves. Now imagine that same trigger running not on arbitrary labels, but on the thing your ancestors used for 200 millennia. Physical appearance. Research by Robert Cialdini and his colleagues on the principle of liking shows consistently that similarity is one of the most powerful predictors of trust and compliance. People are more likely to say yes to someone who resembles them, more likely to vote for them, more likely to believe them, more likely to feel that their interests are aligned, not because they have gathered evidence, because a part of the brain that evolved long before evidence gathering existed has already cast its vote. You see this play out in ways that feel completely ordinary. You meet someone from your hometown and feel an immediate warmth that has nothing to do with their character. You hear an accent that matches yours, and your guard drops slightly, almost imperceptibly, even if you are aware it is happening. You look at a face that has the same rough architecture as the faces you grew up with, and something in you decides, provisionally, quietly, this one is probably not going to hurt me. That decision is being made in your amygdala, the almond-shaped cluster of neurons deep in your brain that is responsible for threat detection, emotional memory, and the rapid appraisal of whether something in your environment is dangerous. It is one of the oldest structures in the human brain. It does not wait for your prefrontal cortex to finish thinking. It fires first and asks questions later. Studies using fMRI technology have shown that the amygdala responds differently to faces from different racial groups, and that this effect is stronger under conditions of uncertainty or cognitive load, meaning when you are tired, distracted, or overwhelmed, the bias gets louder. Your ancient threat system takes over more of the processing. The nuanced, effortful part of your brain that can override first impressions gets drowned out. Jennifer Eberhard at Stanford has spent years studying exactly this. Her research shows that these automatic associations do not require conscious prejudice to operate. They can run in people who explicitly reject bias, who score low on implicit association tests, who would describe themselves as deeply egalitarian. The machinery is older than the values. The machinery does not care about the values. That is the uncomfortable truth sitting underneath all of this. The trust signal your brain sends when it sees a familiar-looking face is not a reflection of your character, it is a reflection of your evolutionary history. A history in which genetic similarity really was a reasonable proxy for shared interest. A history in which strangers really were more likely to be threats. A history in which the cost of trusting the wrong person was not awkward, not inconvenient, but fatal. Your brain is not broken. It is running very old software on a very new world. Because the world has changed in ways that make this shortcut not just unreliable, but actively misleading. You now live in cities of millions. You interact with strangers every single day. The people who look most like you are not necessarily the people whose interests align with yours. A financial advisor who shares your ethnic background can defraud you just as thoroughly as one who does not. A colleague who grew up in your neighborhood can undermine your work just as effectively. And the stranger on the other side of the world, the one whose face looks nothing like yours, might share your deepest values, your most precise sense of humor, your exact political instincts. But your amygdala does not know that. Your amygdala is still scanning the savannah. This is what makes the bias so persistent and so hard to dislodge. You cannot simply decide to stop doing it. Telling someone to be unbiased without giving them tools is a little like telling someone not to flinch when a ball flies at their face. The flinch is not a moral failure. It is a reflex, and reflexes require training to override, not intention. What researchers have found does work, at least partially, is exposure and individuation. When you encounter someone as an individual, learn their name, their history, their specific way of seeing the world, the brain begins to root around the shortcut. It starts building a more detailed model. The amygdala's early verdict gets updated by the slower, more accurate systems. Not overwritten, updated. Dan Batson's research on perspective taking showed that actively imagining another person's inner experience reduces in-group bias in measurable ways. Not permanently, not completely, but meaningfully. The brain is plastic enough to learn new patterns, even on top of very old ones. And this matters because the stakes are not small. In-group bias shapes who gets hired, who gets loans, who gets believed by juries, who gets appropriate medical treatment, who gets the benefit of the doubt in 1,000 low-stakes daily interactions that add up over a lifetime into something enormous. The ancient machinery running in individual brains has consequences that scale into institutions, into cities, into entire systems. You did not choose this bias, but you are living with its effects right now in every room you walk into, in every split-second judgment your nervous system makes before you have finished forming a conscious thought. So the next time you feel that quiet loosening in your chest, that signal that says this one is probably okay, it is worth pausing, not to override it, not to punish yourself for having it, but to ask what evidence you actually have, to ask whether the shortcut is serving you or serving a version of the world that no longer exists. Your ancestors needed that signal to survive. You inherited it, but you also inherited something they did not have: the ability to notice the machinery and decide slowly, carefully, and with effort what to do next. You walked into a room full of strangers. Your brain sorted them in seconds. The question now is what you do with that information.